Okay, today is a fun day, as in fundamental theorem of calculus. Catherine kind of hinted at this the other day when she asked her question. That is where we are heading. Okay. Catherine basically asked the question, well, can we take the antiderivative? Like, that's what we've been doing, right? So this is what the fundamental theorem of calculus says. Are you ready? Okay. If a function is continuous on the closed interval, and f is the antiderivative of little f, so big F is the antiderivative of little f, then okay, if we have a continuous curve, then the integral from a to b of f of x dx is the antiderivative evaluated at b minus the antiderivative evaluated at a. Yes. No more Riemann sums. Minus your quiz and tests, because I still need you to be able to do that for me. Okay? But our Riemann sums really have only been effective for polynomial functions, because that's what we have our shortcuts for. Okay? Trying to do anything trigonometric, any rational functions, I don't think you want to even try to do a Riemann sum, right? So we have this fundamental theorem of calculus. Now, I'm going to go ahead and give you a little proof for it. Please don't write it down. Okay, just watch me talk about it. All right, and then we will go through some examples. Okay? So, let's say we have a that equals the integral from a to x of f prime of t and t. Okay? If we derive both sides, remember, you do not need to write this down. If we take the derivative of both sides, we have a prime of x. Something that we'll talk about next week, the derivative of an antiderivative is itself, okay? All right. And what do we know when we take derivatives? Okay? Those two derivatives could differ by a constant, all right? So, we know that a of x and f of x differ by a constant. Okay? Basically, if we take a and we subtract f, we should get just a constant. We're going to call it c. All right? Now, if we plug in a, let's go up here. What's the integral from a to a? 0. So f of a is, or excuse me, a of a is 0. Okay? equals b. Well then, here's b equals f of b minus f of a. Because c is negative f of a, right? Okay. Here you have it, the integral from a to b of f prime of t dt is f of b minus f of a. Okay? I'm never going to ask you to reproduce that, but sometimes it's nice to see where things come from. Okay? Let's be able to use it. All right? So, as long as you can find the integral, as in the antiderivative, you don't have to find the limit of the sum for a Riemann sum. Okay? I will specifically ask you to do a Riemann sum on the quiz and the test, but that is it. Okay? Also, you do not need to worry about the plus c if you have a definite integral. You do not need to worry about the plus c for a definite integral. Why?
You already have a value you're plugging in.
Okay. Okay. And we're plugging in two values, correct? And we are subtracting them.
Mm-hmm.
Okay. So let's just say we did.
Oh, I know. Because the c is in both, we'll subtract the c out.
Yes. Okay. So let's say we take the antiderivative to be that antiderivative plus c, right? And we evaluate that from a to b. Okay, that's the notation we're going to use. Joe's exactly right. If we plug in b, f of b plus c, and then we subtract f of a, then the c's are going to end up canceling out, and you still have f of b minus f of a. So those of you who missed your plus c's on Monday on that little quiz, today you're excited because you don't have to worry about them. All right, first example, the integral from 0 to 1 of 3x squared plus 2 dx. We are finding the area under the curve from 0 to 1 of 3x squared plus 2. You don't need to draw the picture, but I have it up there for you to visualize what this number actually means. Okay? So this is called our definite integral because we have the 0 and 1. 0 and 1 are what we call our limits of integration. Okay? So the first thing we do is we take our antiderivative. Okay, Michaela, what's our antiderivative? Okay. Okay. Since it is a definite integral, we don't have to worry about the plus c. But what we write is we have to evaluate this antiderivative from 0 to 1. That vertical line is the evaluate. Okay? So, first we need to plug in 1 minus, we plug in 0 and the area under the curve is? You always want to plug in B first and then subtract, plug in A.
This is like 10 times easier than any other stuff.
Yep. Okay, so essentially the integral is doing the Riemann sum for you. Okay, when you take the integral, it is adding up all of those infinitely small rectangles. Okay, isn't that fabulous, right? How many of you are annoyed with me right now that I even taught you Riemann sums? I know you're feeling it. Okay? It's a good conceptual foundation, though. Next one. Okay, don't forget all of the work we did at the beginning of January. Okay? 3 radical x we're going to view as 3x to the 1/2. So 3x to the 1/2, that antiderivative would be 3 times x to the 3/2. Huh. That's nice, isn't it? Okay. And we want to evaluate this from 1 to 4. So what we have is 2 times 4 to the 3/2 minus 2 times 1 to the 3/2. What is 4 to the 3/2? 8 times 2. So we have 16 minus 2. The area under the curve from 1 to 4 is 14. Would you like to know a way to check your answers? Get out your calculator. Riemann sum? Well, yeah. Thank you. Okay. How do we take the derivative at a point with our calculator? Math. 8. Thank you. Look at this. Math 9 says FNINT. So math 9. Now, if you have an 84, it just like gives you all the things to type in. How many of you have an 83 like I do up here? Okay. So we need to punch in 3 radical x, comma. Our variable is x, comma. Our limits are 1 to 4. We get 14! We did it right! Woo-hoo. Okay. You need to know how to do math 9 for when we can't integrate and have to use our calculator. But right now it's a tool for you to check your work. Yes?
I got a syntax error.
Do you have an 83 or an 84?
84.
You need to put an X after that so it knows which variable you are integrating in respect to. Yep. 1. Oh, there it is. Yep. All right, everyone got it? All right, let's keep going here. On your quiz Friday, I will see all of the antiderivatives work and the work of you plugging in. Your calculator is just a tool to check right now. Okay, write this down. I also should warn you that I've stepped up my candy supply for Homework Heroes. I now have full-size airheads and Laffy Taffy ropes available. So, yes.
What if, like, when you did it one day, you did candy that day?
Nope. I'd run out pretty fast. Okay, what is the antiderivative of secant squared x? evaluated from 0 to pi over 4. Do you remember when your pre-calculus teacher, potentially myself, told you the unit circle was important? Because you don't want to waste time trying to remember unit circle values when you have to do calculus. What's the tangent of pi over 4?
1.
What's the tangent of 0? Okay, if you go to the Math 9 command to use your calculator to check this integral, make sure you are in radian mode. Any trig function needs to have radian as the mode. Let's check our work. Right? You want the square to be on the top side there? So put it on C. Like, hold on a second. One thing that kind of stinks is we don't have like a secant button, right? We have to use 1 over the cosine and square that. Tell you what, next unit we'll get to use the Math 9 command a lot. Okay? Okay, next example, the integral from 0 to pi of cosine x dx. I want you and your pod to work on this one. Oh my goodness, where is my x? I'm sorry. Sorry. This is interesting, isn't it?
Yes, -0.
You didn't?
I got -3.2 times 10 to the -14.
Let's talk about that. Okay. What's the antiderivative of cosines? Sine of x evaluated from 0 to pi is
0.
0 minus 0, which is 0. Isn't that weird? Why is it 0?
Because like it's positive and negative and then they want to cancel out.
Cosine. What's your sine? Okay, this is one period of a cosine curve. Here's area from 0 to pi over 2. Here's area from pi over 2 to pi. Are those symmetric? One's above, one's below. Boom, cancel each other out. Okay, now, you put it into your calculator. What did it give you?
Almost 0.
Negative 3.14 times 10 to the negative 14. That means you move that decimal over 14 times. So you have 0.00000000003. Your calculator approximates. Sometimes they'll give you nice numbers like 1 and 14. And sometimes they'll give you numbers that you basically need to round to 0 in this case. Okay? When you see like that times 10 to the negative 14. Or sometimes you'll see like 14.0000001. Okay, it's really 14. Your calculator's approximating. Okay? One more example, and then I'm going to give you some time to work on homework.
Is the next lesson going to take longer?
I don't think so. It'll probably be another like half hour. Should we take the antiderivative right now? No.
You survive that.
Do you?
No.
No. Avoid use substitution if you can. We can rewrite this as x to the 1/2 minus 2x to the negative 1/2. Do you agree? Yes?
Yes.
All right. So then our antiderivative would be x to the 3/2 times 2/3 minus 2x to the 1/2 times 2. So can I just write that as 4? All of that evaluated from 1 to 4. So we're going to plug in 4 first. And plug in 1. Okay, 4 to the 3/2 we decided was 8 times 2/3. 16/3. This is 4 times 2. Minus, this would be 2/3 minus 4. In exact form, what's our area? 2/3? Looks good? Question? 2/3.
Yes.
Beautiful. Okay. You have some homework. If you get out your gold sheet, this is what the original assignment was, but then I broke it up based on like bolded and unbolded problems. Don't look at the date, just find where it says 4.4 first fundamental theorem. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 required problems. Okay.